So we're not going to work through the full NAND implementation. You're going to be working through that by yourself. But let's say you've created the schematic. That's a schematic here for a NAND, and you've gone in here to create the icon for it. And the icon goes in here. Now, in order to create the icon, you can click on this one here, click on that, and then place it. And you can use this as one part of the L shape. So you press your Y key. This can head up to here, and this will head over to this section here, and place another one of these and press Y again. Now this time, this one here can come down to there, and we can place this one at this point here. Now what we can do is we can place a circle, so that's a circle there. We'll place that circle and we'll press a Y, double click on it, and you only want to, you can press on this more and then go to here and change it to 180, so you can only see 180 of the pattern. And then you can do Control J, Control J, Control J, 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 and that's us got the start of our AND gate. So we'll just shift this in a little bit. So this is the start of our NAND gate. Now we also need the final circle for the little inversion. So double click on that and we can make that 2 by 2. OK that, and we'll position it this point here, and then we can move these in a little bit. I can move this one in. Okay, and this one here, the output, right, we'll grab the output and we'll position this out here. Okay, so that's the final AND gate, NAND gate, and that's how you're going to build it up physically so you can get the right instance for it. So if you've built up your schematic, it should look something like this, and you'll also have your icon here, which we've seen how to build, and we'll also have the simulation file for the NAND gate here. So this is your simulation file, and you'll notice that I have a SPICE code there for this simulation, which is in the resources section, and it's just been changed a little bit. The rise and fall times are a little bit sharper. That's 0.1 nanosecond. So if everything's going okay and you've ran through your simulation, you should have something that looks something along these lines here. So this follows a NAND function. If both inputs are high, then we're going to get a low output. Otherwise, if any of the inputs is low or both of them are low, then we're going to get a high output. So this is our NAND function, and you'll notice here you can see that the transition points here, when two of these change at once, you can see you get this little spike, which would be expected. So let's continue and we'll do the layout. So this is the completed design for our NAND gate. Notice it's very similar to the NOR gate, but the parallel combination for the NOR gate was on the bottom and the series combination was on the top. But now with the NAND gate, the parallel combination is on the top and the series combination is on the bottom. Just check the schematics to confirm this. So we're going to have our two CMOS devices here in parallel, and we're going to have our two NMOS devices in series. We've got our ground, we've got our A and B inputs, we've got the output here, we've got the gates tied together. Now if you then get in and have a look at the window, 3D window, so this will give us the 3D view. So it should look something like this here. And you can see that we've got the metal 1 running in between the transistors, and we've got the metal 2, which is at the top here, which will be running outside the transistor. So we'll be using these as the contacts to take this block onto a separate block. So now I've gone ahead and I've created the simulation file for the layout of the NAND gate, and this is the simulation file here, and I've taken the SPICE code in here as well. So let's go ahead and we can check on it. We can get in here and we go into Tools and we can go Simulate, Write SPICE deck, and that's it, written the SPICE deck here. We can click on here, we can take our input and our output, we can OK that, and we'll run this. Add plot plane, we'll grab our input, that's our other input, and this is our output here, and you can see that we've got the function that we require, which is our NAND function. So let's quickly go and put the parasitics on this and just see if we can see any difference. So just close that down, get into the file, preferences, and head into the tools, SPICE CDL, and we'll change this to conservative RC. We'll apply that, press OK, get into tools, SPICE, write SPICE deck, and it's written out all of it's worked out the parasitic capacitances and resistances. Okay, just got rid of my image here, so you can see the capacitances C0, C1, C2, and resistances R0, R1, 2, and so on. We can head up into this here, we can take our inputs and our output, OK that there, and we can put the planes on, add plot pane, and we'll take our A, and we'll take our B, and we've got the outputs here. Okay, so that's it, done the simulation with the parasitics added in. So that's us finished this file here. So if you have done everything right over the last few videos, then you should have really the tutorial here, and you should have a NAND and the NAND simulation, and you should have a NOR and a NOR simulation, and an inverter with the inverter simulation. I'll save that, and that's all saved. So we'll go ahead and we'll create a few more basic combinational logic circuits over the next few videos. Thank you for listening. I'll get you in the next video. Goodbye.